have in 5b, right? Okay. So relations, domains, and range. Okay, we talk about relations and domain and range for relations. So first of all, what is a relation? An ordered pair denoted by x comma y, okay, denoted by x comma y, is a pair of elements x and y, in which x is considered to be the first element and y considered to be the second element. What's this? This is actually just a coordinates. Okay, that's just a coordinate. Okay, so if that's the coordinate, x will be the x value, y will be the vertical value. So what is a relation? Definition of relation is a set of ordered pairs. Yes? Okay, so what is relation? Relation is a collection of ordered pairs. So what ordered pairs? Like each coordinate is one ordered pair. So a collection of ordered pairs is just we use the curly bracket and the elements will be coordinates. Okay, the elements will be coordinates. See the S equals to set notation 1, 1, 1, 2, 3, 4, and 4, 5. And like the collection of 4 points. Okay, collection of 4 points. Each coordinates will determine a point. So S is a set that collects 4 points. T will be the same, a collection of 4 points as well for this set T. So every relation determines 2 sets. Okay, so first of all, I have a set. This set is a collection of ordered pairs. I call this a relation. But in every relation, I have another 2 sets. Okay, so in relation, I have another 2 sets. The first set can be domain set, and the second set will be the range set. So basically talking about the x values and the y values. Okay, what is the possible x you can take and what is the possible y you can take? So let's think about the S, domain of S. So what is domain? Domain is the possible x values. What is the x value? Is the first element in each ordered pair. So we have domain of S. We have 1, 1, 3, and 5. So the domain will be 1, 3, 5. And what is the range? Range is the y element. Range is the y element. We have 1, 2, 4, 6. So the range is 1, 2, 4, 6. Okay, same thing for T. Domain of T will be minus 3, 4, 5, 7. Range of T will be 5, 12. You have 2, 12. We only write 1 and negative 6. So 5, 12, and negative 6, which is the range of T. So I'm just looking at what possible x values I can have. What are the possible y values I can have? That's the domain and the range. Okay. So now the following thing, I'm going to talk about what kind of relationship I can have. Okay, how many type of relationship I can have. Some relations may be defined by a rule. Okay, so what's the first type? This is the first type. Okay, so let's write here. Type 1, list ordered pairs. Okay, that's type 1. It's just tell you exactly what in the set. Okay, 1, 1, 1, 2, 3, 4, and 5, 6. I list out. Okay, list out all the points I have, and I have a curly bracket. That's just the simplest way, like of expressing relations. Okay, I have this, I have this, I have this, I have this. Exactly tell you what points I have, how many ordered pairs I have. Okay, for the second one. Okay, this is the type 2. Type 2 is defined by a rule. I'm telling you a relationship between x and y. Okay, I'm telling you a relationship between x, y. Okay, for example, x plus 1 equals to y. So I give you a relationship. So this is defined by a rule. I'm not listing all of that, but I give you a rule instead. And in order to define the relation fully, okay, this is important. In order to define the relation fully, we need to specify both the rule and the domain. Okay, it's not enough. I only tell you a rule. Okay, it's not enough. I only tell you y equals to x plus y. It is also important to let me know what x can take. What is the possible x values? Okay, so for example, y equals to x plus 1. If your x can be, let's say 0 to 1, that will only be like this part, like a part of the graph. But if your x can be r, if your x belongs to r, okay, x belongs to this side and x belongs to r, that will be two different graphs. If x belongs to r, that will be the full linear. But if your x can only be 0 to 1, that only be part of the graph. I will explain this more because that's a really important topic here. But like now what you just need to know is that it can be defined by a rule. Let's have a look at an example. Let's have a look at an example. If the example will make a lot of sense. We have the set. Okay, we have the set here, x, y. Okay, this is a very complex notation, but like it's easy to understand. It's a collection of ordered pairs. X, y is the ordered pair, so it's a collection of ordered pairs such that, okay, explaining to you what is x, what is y, such that y will equals to x plus 1. Okay, that's the rule. Y will equals to x plus 1. That is the rule. Okay, I'm telling you first a relationship between x and y. Second, I'm telling you that x can belongs to a set. X belongs to what? X belongs to 1, 2, 3, 4. Okay, 1, 2, 3, 4. It only gives you 4 points. Okay, your x can only be x equals to 1, x equals to 2, x equals to 3, and x equals to 4. Okay, you can only take 4 values. This is give you the domain. Okay, x is the domain value. So this explaining what is the domain. And the previous one is telling you what is the rule. So if I simplify this a little bit, I will have 1, 2, 2, 3, 3, 4, and 4, 5. That's 4 points, right? Because your x can take 1, 2, 3, 4. That is the possible x values you can take. 1, 2, 3, 4. And then what's the corresponding y value? It will be 2, 3, 4, 5 because it's the x value plus 1. So if I simplify this, I will become the type 1 relationship. Type 1 relation, which is listing out all those 4 points. Okay, so they're actually talking about the same thing. Okay, talking about the same thing. Okay, domain is the set X, which equivalent to 1, 2, 3, 4, a collection of 1, 2, 3, 4, and the range will be the set of Y, which is 2, 3, 4, 5. Okay, just explanation of what are they. Okay, now I'm asking you to draw, okay, to sketch something. Okay, I want you to plot this set. I want you to plot this set. This set is what? It's collection of x, y, where y equals to x plus 1 and x belongs to 1, 2, 3, 4. Okay, so in your mind, I think you will think about x plus 1 is just a linear, right? A straight line linear. But because the x is restricted as 1, 2, 3, 4, what I can do is, okay, when x equals to 1, 1, 2, 3, 4. And when x equals to 1, y will be 2. So here is a point. When x equals to 2, y will be 3. Here is a point. When x equals to 3, y will be 4. Here is a point. When x equals to 4, y will be 5. And then here is the point. It's on a straight line, but you are not connecting them by a straight line. Because what you all have is these 4 points. Okay, what you have all is these 4 points. So ask you to plot, you just plot 4 points. Okay, ask you to plot, you just plot those 4 points. You are not connecting them because your x can only be 1, 2, 3, 4. Okay, your x can only be 1, 2, 3, 4. Okay, like we compare those two. Okay, it's really similar. It's again a collection of x, y, a collection of ordered pairs x, y. Okay, you should be able to know any point on this graph will be order pairs. Okay, any point on the graph will be order pairs. So it's a collection of x, y such that y equals to x plus 1. Where your x belongs to R. What x belongs to R means? It means x can be anything. Okay, so that is the rule and that is the domain. So your domain is everything. Okay, your everything. So your graph will be y, x. Okay, now your x can take anything. So every x value is possible. So you have infinitely many points. So I will choose 2 points, which is this one and this one, because it's the xy coordinates and xy intercept. And then I will sketch a linear here. Okay, so that point is 0, 1, that point is -1, 0, because I can take all the x values. There are infinitely many points, and you collect them all together, that will be the straight line. Okay, that will be the straight line. So you can see we have exactly same rule, all y equals to x plus 1. But for the first one, I only have 4 dots. And for the second one, I have a straight line. So that's the difference. Okay, that's the difference. So let's go back to this point now. You understand now why specify both the rule and the domain. Because you have different graph. Okay, because you have different graph. Different domain will give you different graph, even though the rule looks the same. Okay, so that's type 2, right? Type 2 defined by a rule. So let's say type 3. We have type 3. A relation may be represented by a mapping diagram. This is like something you not really like learn, like you just need to know how it works. We have, this is the x value, this is the y value. Okay, so what is the possible x? The possible x will be 3, 2, 1. What is the possible y? The possible y will be 6, 5, 4, 2. So if you can list out, okay, for this diagram, if I can list out, okay, curly bracket, I will have, okay, start from 1. So the x can take 1, the y will be 2. X take 2, y will be 4, or will be 5. Okay, in between the brackets, you need to have comma as well. And when x equals to 3, that will give you 4, 5, and comma 3, comma 6. Okay, if you're listing that, that will be 1, 2, 2, 4, 2, 5, 3, 5, and 3, 6. Okay, you just need to know how to read that. Okay, just need to know how to read that. Okay, I give this answer here already. Okay, now let's directly go to questions. We have 3 types. First, listing that out. Second, by giving rule and domain. Third, by using mapping diagram. Okay, let's sketch this. Okay, sketch a graph of each of the following and state its domain and range. Okay, tell me which type is this one? Type 1, 2, or 3? 1. Okay, so if it's type 1, you will result only dots. Okay, a dot, a dot, a dot. How many dots? 1, 2, 3, 4, 5. We have 5 dots in this question. Okay, what we just need to sketch is 5 dots. How we can sketch it? Okay, we sketch. X and Y. Okay, first point is -2 and -1. Okay. -2 and -1, which is here. The next point is -1, -1, -1, and -1, which is here. And we have -1 and 1, which is here, and 0 and 1, which is here, and we have 1 and -1, 1 is here, and -1 is here. Okay. So better label them, but it's hard to label. -1 and 1, -1 and -1, -2 and -1, 1 and -1, 0 and 1. Okay, so you have those 5 dots. Here 1, here's 1, here's 1, here's 1, and here's 1. Okay, so what is the domain? What is the domain? Remember, domain is a set. Okay, you must use set notation to talk about that. Domain is a set. Okay, so what's the domain? What is the x value you have? -2, -1, 0, 1. Okay, 4 points. Okay, -2, -1, 0, and 1. So what I will write is -2, comma, -1, 0, comma, and 1. So what is range? Okay, range is a set as well. Okay, range is a set as well. So what's the range for this question? What's the range? Oh, do we have 0? No, okay. So what do we have again? Okay, -1 and 1. Okay, we only have like -1 or 1. Okay, see? We only have y values at -1 and 1. So the range will be -1 and 1 in the curly bracket. Okay, let's have a look at the next one. 2x plus 3y equals to 6. X will be greater or equals to 0. So which type of graph is that? Type 2. So that's the rule, and that is the domain. Okay. By looking at this rule, what type of graph you think you have? What is it? Linear. Yeah, can you see that's a linear? Ax plus by equals to d, that's a linear. So now we have a linear. 2x plus 3y equals to 6. 3y will equals to minus 2x plus 6. Y will equals to minus 2 on 3x plus 6. Okay, the y coordinates must be 0, 6. Right? And what's the x coordinate? X-intercept when y equals to 0, 2 over 3x equals to 6, x equals to 6 times 3 over 2, x is 9. So 9 comma 0. Wait, I'm solving something. No, it can't be correct. No. So that forgot to divide that value by 2. Okay, this value is wrong. Okay, that's a 6, and 6 divided by 3 we have 2. So the coordinates is 0, 2 for the y-intercept. Okay, 0, 2 for the y-intercept. And when y equals to 0, 2 over 3x equals to 2, x will be 3. So 3, 0 for this one. Okay, that's a normal linear, but with restrictions on the domain. So I can't have a full straight line. I will have part of the straight line. Okay, so let's do label those 2 points on the graph first. I have 0, 2 here, and I have 3, 0 here. Okay, if it's the full graph, that will look like this. But because I don't have negative side, okay, my x cannot be negative. It seems like I draw a vertical line at 0. Okay, vertical line 0. I can only take the graph on the right hand side because the x must be greater than 0. So I draw x equals to 0. All the graph on the right hand side will be the possible graph. So therefore, I'm not going to have this graph. I will have only this part of the graph. I don't want to use that color. Okay, I only have this part of the graph, which endpoints is 0, 6. Okay, and with 0, 2 and 3, 0. Because it's x greater or equals to 0, so 0 can be taken, so it's a closed circle. If that's x greater than 0, I should have an open circle there, because I cannot take x equals to 0. Okay, so closed circle and circle for the endpoints is really important. Okay. And also need to label endpoints, right? You need to label endpoints. So you must label 0, 2, and also need to label x, y intercept. So 3, 0 must be labeled. Okay. Any question about this? No? If no question, moving on. Okay, very important thing is, to determine the range of a relation, it is necessary to consider the graph. Okay, it is necessary to consider the graph. So if without the graph, you cannot really 100% sure to say what is the range for the graph. You cannot think about the graph and try to say, oh, that's the range. So you need to sketch it. Let's have a look at this one. Find the range of the relation with rule y equals to x squared minus 4x plus 5. So what is this? What is this? What equation is that? What type of graph is that? Parabola? So how we can sketch parabola? We cannot factorize for this, right? Okay, so what we need to do? Sorry? What we need to do? Completing square? Okay, completing square find turning point is a good way to do it. So I like completing square, so let's complete square for this one. So x squared minus 4x plus 5. Okay, so how we can complete square? We have x squared minus 4x plus half of b squared, subtract half of b squared, and plus 5. So what I will take is the x and take the second term sign and take the third term's constant. So I will say y equals to x minus 2 squared. Okay, minus 4 plus 5, have a plus 1 here. So what's the turning point? What's the turning point? What 2, 1, 1, 2? 2, 1. Okay, 2, 1. Oh, what's that? So 2, 1. Okay, what's the x-intercept? No x-intercept. Okay, no x-intercept. So I'll have the graph here. Okay, that's the graph. Okay, I need to label those 2 points because one is the y-intercept and one is the turning point. Okay, the important thing here is what is the range? What is the minimum y value this graph can take? 1. Okay, the minimum value it can take is 1. Okay, the minimum y is here. Okay, if I can sketch a line, it's here. Okay, that's my minimum y value. That level is 1. So I'm on level 1 now. Okay, and if I keep climbing up, I always have graph. The y value can go really, really, really large. So basically my y value will be 1 to infinity, right? So greater than 1. Think about the notation we learned yesterday. It's 1 to infinity. My y value is y to infinity. So I will say the range is, I can take the value 1, so I will close bracket for 1 to infinity. Okay, so there are a lot of values I can take, but the minimum value I can take is 1. The maximum value I can take is infinity, so it's 1 to infinity. Okay, it's 1 to infinity. Okay, next one. Next one, sketch the graph of the relation x squared plus 2 for x belongs to -2 and 1. And state the range. Okay, so let's sketch this graph. I will sketch this graph normally, okay, like don't talk about the domain first. I will think about what the graph will look like generally. So I have y and x, and when x equals to 0, y will be 2. Okay, I have a point here, 0, 2, which is the turning point. Okay, which is the turning point. Okay, when x equals to 1, when x equals to 1, y value will be 3, right? Y value will be 3. When x equals to -2, y will be -2 squared plus 2, y will equals to 6. Okay, if you can connect those points, that's the shape of your graph, right? You cannot go beyond those points, because if I sketch x equals to -2 and x equals to 1, you will have graph in between those two lines. Your x value will be in between those two lines, which means your graph must be in between those two lines. So you cannot go beyond those two lines. Okay, so the graph, the end point here is -2 and 6 and 1, 3, and the turning point is 0, 2. Okay, so now let's think about what's the range. Okay, range is the possible values. Okay, what is the lowest value I can take? 2, right? I'll start from 2. I can take 2. What is the highest value I can have? Do I need to consider about 3? Do I need to think about the 3 here? Do I need to show 3 in anywhere in between here? No, because 3 is included in this range. Okay, so 2, 3, 4, 5, 6. 3 is in between 2 and 6. So you already include that I will have 3 in my range. So I just need to worry about where is my lowest value, where is my highest value. Is there any value I cannot take in between? There's nothing I cannot take in between 2 and 6. So my range will be 2 to 6. Okay, the range will be 2 to 6. Okay, if I sketch horizontal lines, that's my lowest value and that's my highest value. So my graph is actually in between those two horizontal lines. Okay, so that two level is y equals to 2 and y equals to 6. So your y value will be in between 2 and 6. Okay, next page please. Okay, if I finish this, okay, I'm aiming for finish the next 3 exercise and we will go back to chapter 4. Okay, functions. What are functions? Okay, so we have 4 types of relations. Okay, there are 4 types of relations. Okay, we have 4 types. Okay, so what type we have? We have 1-to-1. Type 1 is 1-to-1. So what is 1-to-1 relation? 1-to-1 relation will be each x will only go to each y value, and each y value can only give you one x value. Okay, can you see that's a 1-to-1 function? So each x corresponding to each y value. So that's a 1-to-1 function. I will tell you how to know like whether a function is 1-to-1 or many-to-1. Okay, part 2, many-to-1 function. So what is many-to-1 function? More than one x values mapping onto the same y value. So let's have a look at here. If I draw a line here, so for this graph, x equals to 1 or x equals to -1, they all give you y equals to square root 8, right? So x equals 1 or x equals to -1, they all give you y equals to square root 8. So if I tell you my y equals to square root 8, I don't know what my x should be. -1 or 1, I cannot decide. Okay, because both x values will give me the same y value. So same thing here. So all the x giving you the same y value 5. Okay, all the x will give you a y value 5. Okay, 1, 5, 2, 5, 3, 5, 4, 5, because they all give you the same y value. Okay. And for this one, x squared. Very easy. Like x equals to ±2, y will equals to 4. Okay, x equals to ±2, y will be 4. So 2x will give you the same y value. Okay, 2x will give you the same y value. Okay, think about next one. 1-to-many. 1-to-many. 1-to-many is like the one telling you. Okay, this many telling you each x will have more than one y value. And this one tell you each y value will only be given by one x value. Okay, 1-to-many means each y can only map into one x, but each x can have two y values. For example, let's think about this one. Okay, when x equals to 1, y can equals to 0 or y can equals to 2. Okay, each x give you two y values. Each x give you two y values. Okay, but each y value can only be given by one x values. Okay, for example, I tell you y equals to 4. Your x must be 3. Okay, your x cannot be any other values. But when I tell you your x equals to 1, but your y value can be 0, can be 2. I don't know which one it should be. So this is a 1-to-many. Okay, so what is many-to-many? Okay, each x is given by more than one y values, and each y value will be given more than one x values. That's a many-to-many. So which is a circle? Okay, circle is the best representation. Okay, so what we have? We have 1-to-1, many-to-1, 1-to-many, many-to-many. So we choose the word one and many to fill in those two boxes, right? right? We select one or many to put in the first line. We choose one or many to put in the second line. You can use the word repeated, like repeat word. Okay, so how do you determine the type of relations? Do you have you have a graph? How do you determine the type of relations when you have a graph? Okay, so when you have a graph. When you have a graph. Okay, so when you have a graph, how you can decide this is a many to one, one to many, many to many, or one to one function. So now you want to select, okay, in this bracket you can have one or many. In this one you can have one or many. How we can decide? Okay, to decide the first bracket, we will use horizontal line test. Okay, for the first we draw horizontal line. For the second, which is, okay, where's the color? Okay, for the second bracket we use vertical line. Okay, so how this line test will work? If a horizontal line can be drawn anywhere on the graph of a function and only ever intersects the graph a maximum of once, the first bracket will be 1, otherwise it will be many. Okay, let's have a look at the examples back here. Let's choose a graph, this one. Let's choose graph 2. Okay, for type 2, this type. Okay, if I draw a horizontal line, this line will touch this graph twice, which is more than once. I'll put a many in the first bracket. Okay, so anywhere will touch twice, except the last point will touch only once, but doesn't matter. I have other place already touched twice. Okay, even though one place failed, you should be a many. Okay, that one should be a many. Even though it's only one point failed, you touch it twice, it still become a many. Okay, let's think about the first one. Okay, for the first one, see, doesn't matter where I draw the horizontal line, always touch once with the graph. So that first bracket will be 1. Okay, first bracket will be 1. Okay, the next thing is talking about the second bracket. Yeah. It doesn't matter with the asymptotes. The asymptotes is not part of the graph. It's just showing your graph is approaching to that value. Okay, just the actual graph here. Okay, the second thing is do the vertical line test to decide what word you will have for the second bracket. So if you do the vertical line test, doesn't matter where you do it, they always touch the graph once. So that's a 1 for the second bracket. But let's see, if you can do here, like they all touch once, so that's a 1 for the second bracket. And if you go this one, okay, twice, except the last point is once, but you still need to write many inside. Okay, so for the circle, can you see like twice is many for the first bracket, and it's all twice for the second one, so it's many to many. Okay, so we draw horizontal line, we draw vertical line, and we try to think about what relationship we have. Okay, next definition. What is a function? Okay, what is a function? Okay, a function is a relation. Okay, such that for each x value there will be a unique corresponding y value. So if I say this I have it here. This is a many to one or one to one. Okay, many to one and one to one relation will be functions. So we have relation here, and we have 4 type. Okay, one to many, one to one, many to one, one to many, and many to many. For those two, they are functions. Okay, for those two, they are functions. Okay, functions. So if you do a vertical line test, and this vertical line test will touch the graph more than once for some point, then this graph will not be a function. Okay, this graph will not be a function. So it must be many to one or one to one relation, then it's a function. Otherwise, it's not a function. So not function are relations, not all relations are functions. Okay, so question is, if you have two coordinates a, b and a, c are ordered pairs of a function. Okay, they are pairs of a function, they are points on a function. What can you say about b and c? What you can say about b and c? So first of all, what is a function? A function is for each x value, each individual x value, you will only have one corresponding y value, right? You have only one corresponding y value. So now you have a, b and a, c. You have two coordinates for the same x value a. Is that possible for a function? It's not possible. So what you can say about b and c? If b and c are the same, okay, if b and c have the same value, then that's still a function. So which means b must be equivalent to c. B must be equivalent to c. If b are not equals to c, then your a will have two distinct values, which not a function. Okay, which not a function. But it says that it is a function. That means b and c must be equivalent. Okay. Okay, next thing is really important is talking about the function notations. So what are function notations? We give function a name. Okay, we name that as f, g, or h. So basically we change y equals to something to fx equals something, gx equals something, hx equals to something. Okay, so in year 10 we have learned function notations. So the normal, the usual letter we use is f, g, and h. So the definition of a function says that for each x in the domain, there's a unique element y in the range such that x, y belongs to f. Okay, so all these ordered pairs belongs to this function. Okay, do not worry about what has been talking about here. It's just a definition thing. But for the first one, what is image and what is pre-image? So the image is the y element is called the image of x under f, or the value of f under of f at x. The element x is called the pre-image of y. Okay, what do you think? What you can think about this? If you say y equals to x plus 1, if you say y equals to x plus 1, x will be the pre-image, y will be the image. Okay, well, how you can think about that? So you put x as a value. They do some operations inside. They add 1 to your x and change your x looking. The x change from 2 to 3. So that's the image for the x, and x will be the pre-image compared to y. So you can think about people taking surgeries. They working is the pre-image and working out is the image, like after that. Okay, so you put some x in and you have some new values out. So it's the pre-image and image thing. So fx. So what is fx? Fx, since the y value obtain a function of x such as substitution into the rule, we use the notation fx in place of y. So basically change y to fx. Okay, change y to fx. So it's not always x here. It depends on what variable you have for the rule. So if you have a squared plus a, then you will say f bracket a equals to this. Okay, f bracket a equals to this. We read this as f of x. Okay, f of x. For y equals to 2x plus 1, we can write fx equals to 2x plus 1. Okay, fx equals to 2x plus 1. f2 means when x equals to 2, what y value you have. Okay, when x equals to 2, what y value you have. fa means when x equals to a, what y value you obtain. So fa equals to 2a plus 1. Okay, now what we can do for this. So now I want to tell you, your fx equals to 2x squared plus x. So this is the place where you insert numbers in. This is the place where you insert numbers in. So it's same as you have a magical box. What you put into the box will transfer to the rule inside. So at the place of x is actually the box. And square and take another box. Okay, so all the place with x will be empty box. So what you put in the front, that will be magically goes to the second half of your equation. So now let's see, we have f3. So if you have f3 in the box, you put 3 in. So it's 2, 3 squared plus 3. That gives you 9, 18, 21. So what is f negative 2? F negative 2 is 2 negative 2 squared plus negative 2. That gives you, okay, 4 times 2, 8. 8 minus 2 is 6. Okay, the last one is a little bit special. So you put x minus 1 into the bracket instead of x. So you put x minus 1 here. Okay, so you will have all x minus 1 in all the boxes. So fx minus 1 equals to 2 bracket x minus 1 squared plus x minus 1. Okay, that's what you're going to have. Can you see the right thing? That's how we work to that. Okay, so the x is actually the place you insert values, you insert things in. And all those 2x needs to be empty box. What you put in the front, what will happen at later on as well. So you will have those notations. Okay, I have those notations. That's how you substitute values into a function. Okay, that's quite important. Okay, so we have next one is function notation. Function notation is important. It's very, very important. We use that all the time in year 11, year 12. Okay, always asking you, so what is function notation? Function notation is a specific way of writing notations. Okay, let's have a look at this. For the function x comma y, let's look at this one. This is a set notation, right? This is a set, right? So we have a collection of order pairs x, y. So y will equals to 2x minus 1, which is the rule. Okay, y equals to 2x minus 1, which is the rule. And then x belongs to 0 to 4, which is the domain. Okay, to start to write function notation, what you need to do is give this function a name. We can call the function f, we can call the function g, we can call the function h. If you like, you can call that abc. So give that function a name. So you will start from that name. Let's call this function f. So we will write f. Okay? And I have those 2 dots. I'm explaining what is it. Okay, I will write it bigger somewhere. Okay, the thing I write in red is always there. Okay, you cannot change that. It must happen at that place. Okay, the next thing you're going to write is the domain. It's the domain for this function. So what's the domain for this function? Which is 0 to 4. So you will write 0 to 4 here. Okay, followed by next thing will be fixed. Mapping to R and you have a comma. Okay, an arrow to R. Doesn't matter what you have right after domain. It's like after domain, you just write an arrow and a R, comma. Okay, that's you must write that in that way. Okay, it's fixed. If the letter I write in red color, that's a fixed notation. Okay, you're not going to change that. What you can change is the blue part. Okay, so what's the next thing? What's the next thing? The next thing will be what is the rule? What is the rule? So what is the name of your function, which is f? Okay, you write f again. Okay, what is the variable? The variable is x. You write fx. Fx equals to what? Equals to the rule. The rule is 2x minus 1. So you have fx. Fx equals to 2x minus 1. Okay, so we finished that. Okay, we finished that. So what we have, let's explain that. This is the name. Name of the function. This is the domain of the function. And that is the rule of the function. And that is still the name of function. This x is the variable. Okay, because you can change variable to b. Okay, you can change variable to a. You can change variable to h. What do you like? You can change the variable. But if you change the x, you will need to change the x at the back as well. All right. Any question about this? How we write function notation? And when we say domain and range for a particular function, we will write dom of f and ran of f. So it's a notation like we write, say, dom of f is 0 to 4, and ran of f will be -1 to 7. Okay, if you can sketch this graph, sketch this linear, you can work out what is the range for this linear. You sub 0 in, you have -1. You sub 4 in, you have 7. So 0 to 7 is the range. Okay, 0 to 7 is the range. So you write RANF is -1 to 7. Can I finish this? I cannot, maybe. Okay, so restriction. Talk about the thing here. Restriction of a function. So what's the restriction of a function? Think about f, g, and h, those three graphs. Okay, for the rule, we have fx, gx, and hx all equivalent to x squared. Okay, the rule are the same. What is different? The different thing is the domain. Okay, domain have x equals to r, x in between -1, 1, and x equals to r plus union 0. So r plus union 0 is all the values greater or equals to 0. Okay, domain is different, but the rule is the same. All the functions looks different. Can you see that? The function, the graph looks different. This is a full parabola, this is like a half of that, and this is half branch of that. So if the thing have the same rule but different domain, they're not the same function. Okay, they're not the same function. Same rule doesn't mean same function. You must have the same rule and same domain, then they are the same function. Otherwise, they're not going to be the same function because you can see the graph looks different. Okay, the graph looks different. So that's what I want to say. So the different letter f, g, and h used to name the functions emphasize that the fact that there are three different functions. Even though they have the same rule, they are different because they have defined for different domains. We call g and h are restrictions of f because it's restricted by f, since the domain are subset of f. Okay, can you see this is a subset of that? Okay, they are subset of r. Okay, they are smaller part of r. So g and h will be the restriction of f. Okay, if you cut your f, adjust your f, you delay some part of your f, that will give you g and h. Okay, that will give you g and h. So that's called the restriction of a function. Okay, okay, I'll talk about this for a little bit, and I'll give you the work as homework to do. So what is the implied domain? Okay, or the maximum domain? Maximal domain. Okay, so implied domain. So what is implied domain? Implied domain is the domain you can take. If I'm not saying what is the restriction domain, like I'm not telling you, okay, you need to restrict your x in between 0 to 4. If I'm not telling you that, we want to take as much as we can for the x. Okay, we want to take as much as we can for the x. When the rule of a relation is written, okay, when the rule is written but no domain is telling you, then it is understood that the domain taken is the largest for which rule has a meaning. The domain is called the maximum domain or implied domain. For example, the maximum domain for y equals to x squared will be r. So y is r because there's no restriction on this graph. Okay, x can take anything. X take anything will give you a meaning for this graph. Okay, x take anything can give you a meaning for this graph. So domain is r. But give you a counter example will be y equals to square root x. maximal domain is 0 to infinity because your x cannot take negative numbers. Okay, it's a square root number. Okay, square root of something. Your x can only take 0 or above. Okay, only can take 0 or above. Which means my maximal domain will only be 0 to infinity. I cannot take anything else. Okay, I cannot take anything else. Okay, so some functions will restrict it like this. Okay, we'll give you restrictions like this. So what are those functions will have restrictions? Most of the function has no restrictions on domain. Most of the function has no restrictions on domain. So what are the functions has restrictions? So function that domain is not R. First of all is the root, okay, assert, where n is the positive even number. So I'm taking square root 2, okay, root 2, root 4, root 6, root 8, all of those functions can only take positive numbers. Okay, can only take positive numbers. So the function inside the gx, what you put under the square root will be greater or equals to 0. Okay, next thing is a fraction. Okay, fraction needs gx not to be 0. Okay, it's the denominator. Denominator cannot be 0. Okay, denominator cannot be 0. Okay, we are not going to talk about log now, but do not cross it out, like it's still there. But I'm not going to talk about log now because we haven't learned log yet. Okay, so log function, there are 3 functions that has restrictions. Okay, one is root, even root functions. Second is fractions with denominator. And the third one will be log. Okay, will be log functions. Okay, so those 3 types. So number 4 is a combination between things. Okay, so hx over a root of gx where n is positive even number. You need your gx greater than 0 instead of greater or equals to 0 because now it's under square root and also it's the denominator. Okay, if it's a square root, I need that greater or equals to 0. If it's a denominator, I need that not equals to 0. So overall, I need this greater than 0, no equals. Okay, if gx equals to 0, the denominator will become 0. So I will have gx greater than 0 here. Okay, for the next one, we have even root and we have hx. So what we need is gx greater or equals to 0. At the same time, I need hx not to be 0. If I show you examples, that will make a lot of sense. Okay, and the last one will be 2 positive even root. You will take a intersection between that. So let's do one example. Let's do one example. Let's see the first one, 2x over square root 1 minus 5x. Okay, you have a square root and the square root is the denominator. What you need is 1 minus 5x to be greater than 0. Right? What you need is 1 minus 5x to be greater than 0. Okay, I'm not going to solve. I'll leave you to solve this, but I'm going to do the next one. The next one, we have a square root and we have a false root. What we need will be 2x minus 5 needs to be greater than 0. And at the same time, 10 minus 3x needs to be greater than 0. Okay, both equations needs to get 0. So you want to find the intersection between that. Okay, you want to find the intersection between those 2 sets. Okay, that needs to be greater than 0. At the same time, that needs to be greater than 0. Okay, next one. I have 2x square root of a quadratic. So what I need is this quadratic greater than 0. Count equals to 0 because it's the denominator. So I need that to be greater than 0. And you're going to solve for that. Okay, so for this, what is the solution? And that will be your final answer. And the last one, you have a square root on the top and you have a denominator with x under the bottom. What you need is 4x plus 1 to be greater or equals to 0 because it's the square root. That thing needs to be greater or equals to 0. and at the same time, you need 2x minus 1 not to be 0. Okay, not to be 0. You cannot have that equals to 0. And you want to find the intersections between that. Intersection. Okay, I will give this as homework, those 4 inequalities, and ask you to solve for that and find the intersection area. Okay, find the intersection area.